Hello everyone, my name is Bruce Robertson. I'm a Quality Improvement Officer with Scottish Borders Council. My presentation is about prior knowledge, why it's important, and how to make it visible. There are two purposes. The first, to explore why prior knowledge is so important in teaching and learning, and the second, to explore ways to make prior knowledge visible. So I'd like to start by asking you a question. The question is, what do you see? Could you look at this picture and take 10 seconds, please, to consider what do I see in this picture? Okay, so same question and a different picture. Could you take 10 seconds, please, and think to yourself, what do I see? And one more picture, same question, 10 seconds, what do you see? So what you see in each picture depends on what you know. In the first picture, I see Bruichladdich Distillery on Islay. I see a distillation vessel. In the second picture, I see Sir Ian McKellen on stage performing King Lear, I think in the opening scene. And in the third picture, I see electrolysis. I see hydrogen and sodium and chloride and hydroxide ions. I see these things becoming hydrogen gas and chlorine gas, for example. I see ion electron equations framed as oxidation and reduction, and all kinds of other things to do with electrolysis. What you see may be the same, but it may not. Different people see different things, and what you see depends on what you know. If we imagine that we were teaching a lesson about any of these things, then what you will learn, or what your students will learn, will also depend on what you know or what your students know. Knowledge builds on knowledge. So I'd like to explore this idea a little bit further by considering the science of how we learn. So our brain has two memory compartments. It's got our working memory and our long-term memory. These differ in a number of ways. Our working memory is where thinking happens. Our long-term memory is where storing happens. We take information in from our environment, and when we do, it enters our working memory, where we can think about it if we're paying attention to it, or we can forget it. We can hold around 5 pieces of information in our working memory at any one time, and it won't stay in there for too long unless we're making a deliberate effort to hold it in there. After about 30 seconds or so, it will be forgotten unless we're making this deliberate effort to keep it in there, unless we're thinking about it. Now, if we are thinking about it, then we can learn it. Learning is a change in long-term memory. That's the Kirschner definition of it. My definition of learning is the development of long-term memory through the accumulation of knowledge, because knowledge is really the currency of thinking, and it's the currency of learning. When we learn something, we develop our knowledge in our long-term memory. The information that we've been thinking about combines with other pieces of information in our long-term memory to develop schema. So these schema are knowledge constructs. Knowledge combines with and builds on knowledge. We've got all sorts of different schema in our long-term memories. Different people have different schema. It's how we make sense of things. It's how we understand the world around us. So we use these schema to help us interpret new information. So when new information comes to us from our environment, we retrieve schema from our long-term memory and use those to make sense of that information. So we're storing knowledge as schema, and then we're thinking about knowledge using schema. Schema, therefore, it determines how we think, and it determines what we learn. And as teachers, we should be interested in finding out what students' schema look like. so that we can add parts which are missing and so that we can correct mistakes and misconceptions. So this quote, I think, from 1968 is very powerful. The most important single factor influencing learning is what the learner already knows. Ascertain this and teach him or her accordingly. So I take that quote from this book, recently published, Paul Kirschner and Carl Hendrick, How Learning Happens. So I really recommend this book to you. And if you're interested in the science of how we learn and how that can have some sort of practical application in the classroom, well, this one I recommend, and also this one as well. Daniel Williams, Why Don't Students Like School? They're great books for any teacher or school leader. Now they would talk about the testing effect. So as well as understanding that it's important to find out about prior knowledge in relation to schema, because knowledge builds on knowledge, we should consider the testing effect as well. So the testing effect is all to do with retrieval. And when we pull or retrieve, recall knowledge from our long-term memory and bring it out into our working memory, the act of doing that strengthens the memory. So if you think of the memory as being a line, relatively thin, faint, and that you retrieve the knowledge from your long-term memory, well, the act of retrieving it strengthens it. The line becomes thicker. It becomes stronger. Every time we retrieve or recall knowledge from our long-term memory, our learning improves. This is called the testing effect. And that's one of the reasons why it's so important to ask students to retrieve or to recall prior knowledge. Well, there's another effect that's worth considering, and that's the hypercorrection effect. And the hypercorrection effect relates to this. Making a mistake with something you are confident about has a more positive effect on learning than making a mistake with something you aren't sure about. So to give an example of that, let's think about the capital of Australia. So I always used to think that the capital of Australia was Sydney, and I was relatively certain about that. The capital of Australia is Sydney. And then in a pub quiz, I discovered I was wrong, and my team discovered I was wrong as well because we got it wrong. But I'd been sure that the capital was Sydney, and then the quizmaster read out the correct answer, which is Canberra. And this is all to do with the hypercorrection effect, because I've now learned pretty well that the capital of Australia is Canberra, because I was pretty confident that it wasn't that. And I made a mistake with that. And this is hypercorrection. If I hadn't been too sure what the capital of Australia was, if I thought, well, it could have been Canberra, it could have been Sydney, it could have been Melbourne, and then I found out it was Canberra, well, that wouldn't have as powerful effect on my learning. So we can't always make use of the hypercorrection effect, but we do need to take advantage of it as and when we can, and the only way we can do that is if we make prior knowledge visible. So I'd like to explore some activities that you can use in class to make prior knowledge visible. The first of these is a KWL grid. These are often quite good at the start of a topic, for example, or a series of lessons on something. You ask students to brainstorm what they already know about the subject and to write it down. You can ask them to write down questions or things that they want to know about in this topic or this series of lessons. And then as you work your way through the topic or series of lessons, perhaps when you get to the end, you ask them to summarise what they've learned. So a KWL grid. It's a useful way to elicit prior knowledge. Concept cartoons can be used in any subject. Here's an example from science. I'll give you a moment to have a look at it. So you're using these to get students to think about what they already know. I think they're most powerful when they're deliberately designed to tap in to common misconceptions that students have about a particular topic. This example's from science, this example from English. Very useful for getting students to think, very useful for getting students to discuss, and very useful for getting formative information to the teacher about prior knowledge. Empty your brain activities, brainstorms, write down everything you know about electricity, for example, U-shaped valleys, Hamlet. True or false questions, which may be closed questions or may be open. So some examples of some closed true or false questions. And the last one being a more open question. With all of these activities, we're really interested in trying to find out about the prior learning of every student. And that's a big challenge for us as teachers. There you are, the pink circle at the front of the room, and there is your class with around 30 students in it. And we want to find out about the prior learning, the prior knowledge of every student in the class. And while it's relatively straightforward to find out about the prior knowledge of 1, 2, 3 students, it's far more challenging to find out about the prior knowledge of everyone, and that's where I think that show me boards come in. So if you imagine that you're teaching a lesson, a chemistry lesson, and you want to know about their prior knowledge in relation to aluminium ions, you might ask them to draw the chemical symbol for an aluminium ion on a show me board. And you might see this, and then this, and this, and this, and this, and this. And it's giving you as the teacher all sorts of formative information about their prior knowledge. It's letting you diagnose misconceptions. It's letting you respond to them in your teaching, either in that lesson, giving live feedback, or you're making a mental note of that to come back to it in the next lesson. So, as a summary, finding out about prior knowledge is important for 3 reasons. The first relates to schema and the idea that what we end up learning relates to what we already know. What we think about depends on what we already know. The second is to do with the testing effect. This is the idea that when you retrieve knowledge from your long-term memory, the memory of it is strengthened. Retrieval has a positive impact on learning. And the third relates to the hypercorrection effect, which is when we're relatively sure about something, when we're very confident about something, and then we get that wrong. That has quite a powerful impact on our learning, more so than if we weren't really sure. But the only way we can take advantage of the hypercorrection effect is to engage students in activities which get them to think about things that they think they already know. So it links to prior knowledge. So ways of making prior knowledge visible, for example, there are many others, but the ones I've used as examples: KWL grids, concept cartoons, empty your brain, true or false statements. And with all of these things and any other activity that you're using, I would always push for the use of show me boards, because this helps you as the teacher to make the prior knowledge of every student visible. So, purpose of my presentation was to explore why prior knowledge is so important in teaching and learning, and to explore ways to make prior knowledge visible. Thank you very much for your time.